Welcome to the Explainer. Today, we're taking the sometimes abstract world of mobile programming and turning it into a hands-on builder's journey to create an Android app. If you've ever caught yourself staring at your phone, wondering how those little icons actually become rich, interactive experiences, well, you're in the right place. Let's get to it.
Okay, here's our roadmap. We'll start with a quick welcome to mobile programming. Set up Android Studio, unpack the project structure, design the user interface, and finally, bring the app to life.
Welcome to Mobile Programming, the blueprint.
Before we write a single line of code, we need to know what we're actually building. Mobile computing is basically how we engineer communication today. We're talking about building interactive apps designed specifically for smartphones. Think WhatsApp or Uber. It's literally about putting incredibly powerful tools right into a user's pocket.
Now, before you break ground, you have to choose your architecture. Native apps, which are built specifically for Android or iOS, give you the absolute deepest integration with a device's hardware. Web and hybrid apps, on the other hand, give you broader reach from a single codebase. But for us, we're going all in on native Android apps to get that top-tier performance.
Section 2. Setting up Android Studio. Laying the foundation.
With our blueprint in hand, let's lay the foundation by setting up the official, integrated development environment. Honestly, for an environment that gives you so much power, the setup is surprisingly straightforward. It really just boils down to 3 quick steps. Open the software, select an activity, and configure your project.
The very first major choice you make in the setup wizard is picking an activity. In the Android ecosystem, an activity is really just a single screen with a user interface. It's kind of like looking at a single room inside the house you're building.
For anyone just starting out on this builder's journey, beginning with a clean slate is definitely the way to go. Choosing the empty activity option gives you a blank canvas. No complex, pre-generated code getting in your way, just a fresh start.
Finally, we configure the project details. We choose a name, and we lock in Kotlin as our language. But here's the really strategic part, setting the minimum SDK. By setting this to something like Nougat, you're literally dictating the absolute oldest operating system your app will run on. It's a balancing act between using the newest, flashiest features and making sure your app actually works on as many phones as possible.
Section 3. Unpacking the project structure. The construction crew.
All right, foundation is poured. Let's look at the internal directory structure, essentially our construction crew and materials. The key here is separation of concerns. Your app isn't just one massive file. Think of it like this. Your XML files act as the visual frame. Your Kotlin file? That's the electrical logic. The Android manifest is basically your zoning permit for things like internet access. The res folder holds all your static assets like images. And Gradle? Well, Gradle is your automated building crew putting the whole shebang together.
Section 4. Designing the user interface. Building the frame.
Let's see how this actually builds out visually using those XML layouts we just mentioned. Every Android UI relies on a strict structural hierarchy of ViewGroups and Views. A ViewGroup is essentially an invisible container that manages the spacing of its contents. The views inside, those are the actual widgets the user touches, like the buttons, the images, and the text fields.
You can really see that parent-child relationship play out. A single screen layout branches down into nested elements. A main view group holds individual views, sure, but it can also hold other view groups. This means you can create incredibly complex, beautifully organized screens just by nesting these basic building blocks. It's like a giant puzzle.
Depending on what you're designing, you've got different structural frames to choose from. You might use a simple linear layout to just stack items in a row, or you could use a constraint layout, which is an absolute game changer. It lets you position elements relative to each other, meaning your app will adapt seamlessly no matter what size screen it's running on.
So here's the direct visual result of our XML blueprint. We've got a perfectly functional layout with an input field, called an edit text, and a button. They sit exactly where we want them, entirely based on the text-based rules we mapped out in our XML file. Pretty cool, right?
We can even group specific widgets together to enforce logic. Say you wrap a few radio buttons inside a radio group container. Android automatically steps in and ensures the user can only pick one option at a time. It's a fantastic example of your UI design doing some of the heavy lifting for you.
Section 5. Bringing apps to life, flipping the switch.
Okay, so our building looks great from the outside. The walls are up. But a beautiful button that doesn't actually do anything is, well, just a picture of a button. So how do we install the electricity and capture a user's tap?
The magic happens right inside our main activity.kt file. This is where we bridge that visual XML design to our backend code. When the app launches, we load up the layout using a command called setContentView, and then we start writing the interactive logic.
It really just comes down to a simple chain of action and reaction. First, we find the visual button in our code by its unique ID. Then, we attach a listener to it. That listener literally just sits there, waiting for the user to click. Finally, we define the exact block of code that fires off the absolute second that click happens.
And here is the final product. Clicking Submit triggers our logic, grabs the selected radio button, and pops up a tiny message at the bottom of the screen, which is called a toast. Just like that, the circuit is complete. The app is officially alive.
By moving from the abstract ideas of mobile computing, setting up your IDE, framing your screens with XML, and wiring everything together with Kotlin, you have mastered the builder's journey. You've taken a concept and engineered it into a working, interactive reality.
You now have the foundational tools and the structural knowledge you need for Android development. You know exactly how the pieces fit together, so the only question left to answer is, what problem are you going to solve with your very first app? Thanks for joining me on this explainer, and happy building!